All right, so we're going to have fun in this video. We're going to do word problems, everybody's favorite. But before we get to the word problems, we're going to look at how to solve a formula for a specified variable. So in previous videos, we've solved linear equations, and it had one variable in it, and you had to solve for x. Well, now it's pretty much nothing but variables, and they want you to solve for a specific one. All right? But don't worry, it's the same thing as what you did when you solved for x and you had numbers. All right? So when solving these things, whatever they're asking you to solve for, you want to get that by itself on one side of the equal sign and everything else on the other side. And the same properties still apply. You can add, subtract, multiply, and divide the same number to both sides. Okay? And we're going to do the same thing. If an equation has a fraction in it, we're going to get rid of the fraction first. Okay? So let's go ahead and get started. So we've got D equals RT. And we want to solve this thing for R. So if you notice here, I've got what? I've got T times R. So how am I going to get rid of the T? Well, I divide both sides by T. And so that leaves me with R equals D over T. And there's your answer, because see, the T's cancel out there. Now, if you want more detail on this and more examples, I've got a video just by itself on solving formulas for a specified variable. You can check that one out. And it's more examples and stuff like that. All right, so let's look at the next one. We've got C equals 5 over 9 times F minus 32, and we want to solve it for F. Now, there's a couple of ways that we could go about doing this. And to solve this, I mean, the first thing we would think is, hey, let's multiply everything through by the common denominator, okay? Which in this case would be 9. And we could do that, but there's actually a way to work this that's a little bit easier, okay? So the first thing I want to do is I want to go through and multiply everything through by 9, okay? And show you what that looks like, and then I'm going to come back and work it again, not doing that, okay? So generally the rule is, well, not really a rule, but generally what you want to do is if you have an equation with a fraction in it, you want to get rid of the fraction, okay? Now, that's not 100% of the time you want to do that, because sometimes it's going to be easier not to do that. And to me, this is one of those problems. So let's look at it both ways. So I want to multiply everything. I want to multiply everything by the common denominator. So the common denominator is 9. So I'm going to multiply everything through by 9. All right, so that's going to give me 9C. The 9's cancel, and then I get 5 times F minus 32. All right. And then, well, actually, what could we do here? This is 5 times this, right? This is like one term inside the parenthesis. So I could actually divide both sides by 5, okay? I could divide both sides by 5, or I could distribute the 5. It doesn't matter. Well, let's just divide both sides by 5. So that's going to give me 9/5 C is equal to, and see the 5's cancel, F minus 32. And then all I need to do is what? Add 32 to both sides. And so that's going to give me F is equal to 9/5 C plus 32. And there's your answer. All right. Now, that wasn't very difficult. Now, if you would have distributed everything by 5, it wouldn't have made it that much more difficult. It would have been a little more involved, but you could have done that and you would have gotten the right answer. Okay? All right. So let's go back. I multiplied everything by 9, right? And got rid of the fractions. And, it's not that bad. It's not that bad at all. But if we don't do that, basically what it's going to do is save a step. Okay? So let's take a look at that if we don't multiply everything through by the common denominator. So I have this 5/9 here in front of the parentheses, okay? And if what I'm fixing to do in this problem right now, if it confuses you, then just do it the other way, okay? So basically, I want to get a 1 in front of the parentheses here. So if I multiply both sides by the reciprocal here, by the 9/5, look what that does. All right, see the 9 and the 5 cancel, so I'm left with 9/5 times c, and then this is just 1 right here, so 1 times this is f minus 32, and then I'll add 32 to both sides, and so that's going to give me 9/5 c plus 32 equals f. And there's my answer. So what it did, it kept us from having to divide by 5. Okay? Basically what we did is we just did it all in one step right here. Okay? Either way is correct. All right? Whichever one works for you, that's how you work it. Okay? The thing you've got to understand with math, with this stuff right here, you don't have to repeat what your teacher does. You don't have to do it exactly like they're doing it step by step. Now, in some cases, there's just one way to do it, okay? But if something's easier for you and you see an alternate way to do it that might be easier for you, but remember, it's got to be mathematically correct what you do, then, there's nothing wrong with that. All right, so let's look at this one. We want to solve for h. So we want to get h by itself. So first, let's get rid of the fraction. Let's get rid of the 1/2. So I'm going to multiply everything by the common denominator, which is 2. All right, and you can see the 2's cancel. So I'm left with 2a equals b times h. Now, I got to get h by itself. I have b times h. So I'm going to divide both sides by b. And so that's going to, and the b's cancel, so I'm left with h equals 2a over b. All right. Now in this one, we want to solve for x. All right, so I've got a plus by here. So let's move this to the other side. So let's subtract by to both sides. That's going to leave me with ax equals c minus by. And then all I do is I divide both sides by a, because I got to get rid of the a. So that's going to be x equals c minus by over a. And here's your answer. Now, this right here is what throws students off a lot. Sometimes they work these problems, and then what's the first thing you do after you work a problem? You go straight to the back of the book and you look to see what your answer is, okay? And you look at the answer, well, that doesn't look like what I have, okay? And sometimes it may not, but your answer's still right. Another way that you could write this answer is if you split this up. That's a correct answer too. What's the back of the book going to have? Have no idea. Depends on what book you're looking at. Okay? You might see this, you might see this, but the thing about it, both of them are correct. Okay? All right, so let's look at this one. We want to solve this one for R2. Now, this R1, R2, R3, R, all that is is that's just letting you know those R's are not the same. Okay, they're just different R's. It would be the same thing as if you had something like this. Okay, it's just showing, okay, I got different letters underneath in the denominators. Okay, that's all it is. I mean, we could solve this for C. Okay, it's the same thing as solving this for R2. It's just the letters are different. And, you know, that's just this formula. It's a resistance formula. Okay, so first, let's get the common denominator and multiply each term by the common denominator. So my common denominator is R, R1, R2, and R3. I just multiplied them all together. All right, so there's my common denominator. I'm going to multiply each term by the common denominator. And I hope I don't run out of room. Maybe I won't. I think we're good. All right. So all I did, it looks confusing, doesn't it? But all I did is I wrote the common denominator next to each term. That's all I did. And I hope I didn't write something wrong. I don't think I did. All right. You know, you get to work on these problems and all the excitement, and you can make a careless mistake. All right, so let's cancel. So that R and that R cancel. The R1 and the R1 cancel. The R2 and the R2 cancel. The R3 and the R3 cancel. So we're left with R1, R2, R3 equals R, R2, R3 plus R, R1, R3 plus R, R1, R2. All right. So now what we're doing is solving for R2, right? That's what we're doing. So remember, okay, don't freak out or anything. Just remember, whatever you're solving for, get that to one side of the equal sign and everything else to the other side. So I'm solving for R2. Look at this. This term has an R2, this term has an R2, and this term has an R2. So I'm going to subtract these two terms to both sides. So I'm going to subtract R, R2, R3, and I'm going to subtract R, R1, R2. So subtract R, R2, R3, and R, R1, R2. Subtracting those to both sides. And so that's going to leave me with R1, R2, R3 minus this one, R, R2, R3 minus this one, R, R1, R2, and that equals, and then see that one and that one go out, and I'm just left with this, R, R1, R3. All right. So all we're doing is, the way we're solving this is just like you've solved all of your equations before, your linear equations before. All right. Whatever you're solving for, that comes to one side. Everything else has to go to the other side. So remember, our goal, we have to get R2 by itself on one side of the equal sign. Now you can see we have a R2 here, here, and here. So we go back and we remember how to factor. Okay. We can factor out a greatest common factor. We can factor out the R2. And factor it out of here. That leaves us with R1, R3 minus R, R3 minus R, R1. And that equals R, R1, R3. And then what do we do? Well, we're going to divide both sides by this. All right? All right, so we're left with R2 is equal to R1, R3 over R1, R3 minus R3 minus R1. And provided I didn't write something down wrong, careless mistake or something, that's your answer. Okay? So it's not bad. Okay? That's not too bad, but there's your answer. All right, so now let's get to the fun stuff, the word problems. And like I said, if you want to see more of those, just search my channel for solving formulas for a specified variable. And there's more examples. All right, so it says Ben bought a Ford Mustang GT for a total cost of $18,966, including sales tax. So that's the cost of the car plus the sales tax. Okay, so I'm sure that sales tax added on. They're probably not figuring in license, and title. Okay, so we're just going to go on to the assumption the regular cost plus the sales tax added together. This is how much he paid, and the sales tax is 9%. Then what amount of tax did he pay? So they want to know how much were the taxes. Okay, so whenever you're dealing with a word problem, you've got to identify your variable. What's X? Okay, well, let's look and see. So the sales tax is that. Then what amount of tax did he pay? So we're looking for sales tax. Well, they give us the total cost that we paid. So I guess what we would need to do here is maybe find out how much the car cost. How much was the price of the car? And then if we find that, we can do this. We can do this minus whatever we find for X minus the original price of the car. Okay? All right. So I'm going to let X equal the price of the car. All right? That's going to be the price of the car. Now, how do we do this? How do we do this? Well, whenever you buy something, you've got the price, right? You've got the price of the car. And then we're going to add on the sales tax. Okay, we're going to add on the sales tax. Well, how do you find the sales tax? Well, it's the rate, the sales tax rate, which in this case is 9%, and we would write that as a decimal, so 0.09. And how do you figure out how much tax you got to pay? Well, it's the tax rate times the price of the car. Okay? So to figure out the tax, it's the price of whatever you're buying times the tax rate, whether that's 9%, 10%, or whatever. And you take this amount, this is your tax. This is how much you're paying in taxes. And you add that to the original price, and that would give us the total cost here. So if that's plus the 0.09x, that has to equal 18,966. All right. So I've got the price of the car plus the sales tax is equal to this. Well, now we have a problem to solve. Now, on this one, we know that whenever we're solving an equation and we have a decimal, we have decimals, get rid of the decimals, right? I worked a problem in an earlier video where we got rid of the decimals. Now, you can do that, but there's really no need to do it on this problem. And this is what you've got to learn to do is, well, this is what the teacher did. He said to do this all the time, Yeah, sometimes the teacher says, when you have fractions, get rid of the fractions first. When you have decimals, get rid of the decimals first. That's going to work. That's going to work all the time. Okay, that will work. But sometimes it's a little more difficult, or it's a little more involved. I wouldn't say difficult, but a little more involved to do that. And sometimes, like for instance, this problem, when you see it, this is just 1 plus 0.09, which is 1.09x equals 18,966. Now see, that wasn't difficult, was it? Now, when I say, get rid of the decimals and stuff like this, that's when you have like all of these terms would have decimals in them. Then I would go ahead and get rid of them. But if you've just got one term with a decimal, and that's a 1 right there, well, just add them together. And then the only thing you have to do here is divide both sides by 1.09. And so that's going to be x is equal to 17,400. Now remember, this value right here, that is the price of the car, right? That's the price of the car. And they want to know what amount of tax did he pay. So the amount of tax is equal to the 18,966 minus the 17,400. It's the total price you paid minus the actual price of the car, and that's going to leave you with $1,566 is what you paid in taxes. All right, so let's look at the next problem. It says in 1974, workers found 3 pits that contained life-size sculptures of warriors, which were created to guard the tomb of the emperor. The largest rectangular pit has a length that is 40 yards longer than 3 times the width. If its perimeter is 640 yards, what are the length and the width? Okay. Well, if we see a rectangle, obviously the easiest thing to do to find out the length and width, just get a tape measure and measure it, right? Well, you can do that, but in math, we got to make it a little more difficult. We got to solve it. Okay? We got to get practice doing math problems. So let's do this. So we got a rectangle. All right? Now, we got to let x equal something, don't we? So x is going to be what? Well, let's see what they tell us. So here's where they start talking about the rectangle from here on. It says the largest rectangular pit has a length that is 40 yards longer than 3 times the width. So what are they telling us about in that statement? Are they telling us about the length, or are they telling us about the width? Well, they're telling us the length, right? It says it has a length that is, and then they tell us the length. So that means we're going to let x equal the width. You want to let x equal what they don't tell you about. Okay? So now, if that's the width, then what's the length? What does that equal? Well, let's see. 40 yards longer than 3 times the width. 40 yards longer, so that means plus 40, right? And it's 40 yards longer than 3 times the width. So that's what? 3x is 3 times the width, and it's 40 yards longer than that. So that's the plus 40. And so now let's label this thing. We'll call this the width. We'll call this the length. Okay. Now you might be thinking, well, how did you know to call that the width, and how did you know to call that the length? doesn't matter. You could call this the width and you could call this the length. It makes no difference. It doesn't matter which one you call which. Okay. So now, what else does it give us? It says, if its perimeter is 640 yards, so that means the distance all the way around is 640 yards. Okay? So we know this side's x, and we know this is 3x plus 40, right? Because this side is the same as this one, and this side is the same as this one. Now, let's just come over here to the side, and let's say that we have a rectangle. And let's just call this the length and this the width. So that's the width and that's the length. Remember, the perimeter is all the way around, right? So the perimeter is the length plus this width plus this length plus this width. And then if I combine like terms, that's twice the length plus twice the width. That's the perimeter. So there's your formula for perimeter. Just remember that. If you forget it, then do what I did right here, and you got your formula. Just know, all you really got to know is the perimeter is the distance all the way around. You just add all the sides up. But now that we have this formula here, so we know that the perimeter, which is what? 640, right? That's what they give us here, the perimeter, is equal to twice the length. So twice the length. So what's the length? That's 3x plus 40 plus twice the width. So twice the width, what's the width? It's x. And now you just have a simple equation to solve. Solve it for x. So that's 640 equals 6x plus 80 plus 2x. And then remember, before you start adding and subtracting to both sides, combine like terms. So I've got 640 is equal to 8x plus 80. And then I'm going to subtract 80 to both sides. And so that is going to give me 8x is equal to, what is that, 560? And then divide both sides by 8. And so I'm going to get x is equal to 70 yards. That's x. This is the width, right? Now, what's the length? Well, this is the length, right? Or, I mean, we got it written here what the length is, 3x plus 40. So let's see. 3x plus 40 is equal to 3 times, well, what is x? X is 70. Plus 40 is equal to, well, what would that be? That's 3 times 70 is 210. 210 plus 40 is 250 yards. And this is the length. And so there's your answer. That's the dimensions of the length and the dimensions of the width. All right. Let's look at the next one. It says a group of hikers from Tulsa hiked down into the Grand Canyon in 3 hours and 30 minutes. Coming back up on a trail that was 4 miles shorter, they hiked 2 miles per hour slower, and it took them 1 hour longer. What was their rate going down? All right. So these distance, rate, time problems, I would make a table and just fill the table out. That's all you got to do. So let's see our table here. See what we can do. So we've got this. We've got, let's see, going down. going up. We've got distance. We've got rate. Let's do this. We've got distance, rate. And we've got time. And all we have to do is fill that out. Fill it out. Okay, so let's fill out everything we know. So it says a group of hikers from Tulsa hiked down into the Grand Canyon in 3 hours and 30 minutes. So hiking down, it took them 3 hours and 30 minutes, which is what? 3.5 hours. So this time is 3.5. Okay. Coming back up on a trail that was 4 miles shorter, they hiked 2 miles per hour slower, and it took them 1 hour longer. Okay, so that means that coming back up, that was 4.5 hours, right? Okay, that was 4.5 hours. So now let's start figuring out this other stuff. So let's see. They don't tell us much about when they were hiking down. It just says it took them 3 hours and 30 minutes. So coming back up on a trail that was 4 miles shorter, they hiked 2 miles per hour slower, and it took them 1 hour longer. All right, so what was the rate? What was the rate going down? What was their rate? We don't know. That was X, right? So if their rate going down was X, what was the rate coming back up? X minus 2, right? They hiked 2 miles per hour slower. You see that? 2 miles per hour slower. So they don't tell us anything really about the distance, but we do know, well, the one thing they tell us is that the trail going back up was 4 miles shorter, right? Well, I know that this distance is what? 3.5x. This distance is 4.5 times x minus 2. Because don't we know that distance is equal to rate times time? All right, distance is rate times time. So we can actually set up an equation here involving distance, right? They tell us that it was 4 miles shorter. So these two distances here, that's 4.5 times x minus 2 is equal to 3.5 times x minus 4. All right. Now, man, can this be confusing? And the question you get all the time, well, why did you subtract 4 over here? Because it says this distance is 4 miles shorter, right? That's what it says in the problem. That the distance back up, it was 4 miles shorter. Well, let's look at that. These two are not equal, right? They're not equal. Remember, this is 4 miles shorter. So that means this side over here is 4 miles longer, right? It's 4 more than this side over here. Well, if I'm putting an equal sign in front of them, I've got to make them equal. So if I know this is 4 miles longer, I have to subtract the 4 to make them equal. And I know what some of you are thinking right now. Yes, if you wanted to, instead of putting the minus 4 over here, you could have put plus 4 here. Because see, it's 4 miles shorter. I could have wrote plus 4 on this side and then just left the minus 4 off there. And you might be saying, well, why didn't you do that? I don't know. I just didn't. Okay? It doesn't matter. That's the thing. Okay? As long as it makes sense, why I subtracted 4 to one side, is if you understand that, you're good. If you understand why I could have added 4 to the other side instead of doing this, then you're in good shape. Okay? I've got to make the two sides equal before I can set them equal to each other. All right? So now, let's solve. And so, well, once again, we've got decimals, right? So I could multiply everything through by by 10, right? To get rid of the decimals. I could do that. But let's look. And yes, I do have more than one decimal. But look, I'm going to distribute that 4.5, right? And I'm going to have a 4.5x over here, and I'm going to have a 3.5x over here. And I'm going to end up subtracting the 3.5x to both sides. What's 4.5 minus 3.5? It's 1, isn't it? You see that? So let's distribute. 4.5x minus 4.5 times 2 is 9. That equals 3.5x minus 4. And then there you go. Let's subtract 3.5x to both sides. And let's add 9 to both sides. And so that gives us x is equal to 5. Now, what in the world do we have here? We've got x is equal to 5. That's this x right here. That's the rate that they were traveling downhill. And what do they want to know? What was their rate going down? And that's what it is. 5 miles per hour. Okay? There's your answer. And look, if your teacher wanted you to, they could say, what was the distance downhill? Well, then you just take the 5 and plug it in here, and that gives you the distance downhill. If your teacher wanted to know the distance uphill, you take the 5, plug it in for x, figure that out. What if the teacher said, what's the rate uphill? Plug the 5 in, 3 miles per hour uphill. You see that? So just this one problem, you could ask a student to find 4 or 5 different things. So let's look at example 5. It says a pharmacist needs to obtain a 70% alcohol solution. How many ounces of a 30% alcohol solution must be mixed with 40 ounces of an 80% alcohol solution to obtain a 70% alcohol solution? All right, so the problems, these mixture problems, they're not that bad. What I like to do on these is I like to draw the buckets. All right. Now, I've got a bucket that is, let's see, 30% alcohol. I've got another one that is 80% alcohol. And then what I want total, after I mix them together, I want to end up with a 70% alcohol solution. Okay? Now, what does it say? It says, how many ounces of a 30% alcohol solution? So that's how many ounces. So I'm going to have X ounces. Must be mixed with 40 ounces. So this has 40 ounces of an 80% alcohol solution to obtain a 70% alcohol solution. So when I take this bucket and I dump both of them into this one, how many ounces am I going to have total? Well, I'm going to have what? X plus 40, right? That's how many ounces, however many ounces of this, plus however many ounces of this, that's going to be x plus 40. Add the 2 ounces together. All right, so now let's set up our equation. So I got 30% of x ounces plus 80% of 40 ounces plus 70% of this. So that's going to be 30%, that's 0.3 times the number of ounces plus 0.4 times the number of, times 0.8 times the number of ounces equals 0.7 times the number of ounces. And that's your equation. Okay, that's your equation. Now let's solve. Now on this one, I would probably get rid of the decimals on this one. I've got them in all 3 terms. So let's multiply everything by 10. Okay, and if I multiply everything by 10, that's going to move the decimal 1 place to the right, and that will get rid of our decimals. So let's do this. Let's just put all that in parentheses times 10. Okay. See, at this point we've gotten to where we're good at doing all this stuff, so we can do little things like this instead of writing it all out. Now, if you need to write it all out, 10 times 0.3x plus 10 times 0.8 times 40 equals 10 times 0.7 times x plus 40. That's fine. Go ahead and do that. Okay? But let's just do this. So basically, all this is going to do, when I distribute that 10 to all of them, all it's going to do is move the decimal 1 place to the right. So that's going to give me 3x plus 8 times 40 equals 7 times x plus 40. Now, what some of you are thinking probably is, well, how come you didn't multiply the 10 times the 40? How come you didn't multiply the 10 to the 40? Why'd you just multiply it to the 0.8? Well, let me show you. So basically what we have here is this, right? That's what it is. 10 times this. Well, when you multiply that, well, I'll tell you what, but that's what you got. You got 3 numbers you're multiplying together. Let's use some simpler numbers. What if I had 2 times 3 times 4? How would you multiply that? 2 times 3 is 6, and 6 times 4 is 24, right? You don't do 2 times 3 is 6, and then 2 times 4 is 8, and then multiply those and say it's 48, do you? Okay, so remember, this is 10 times 0.8 is 8, and 8 times 40. You see that? Same thing for this. 10 times 0.7 is 7, and then 7 times this. All right, that's how that works. So now let's clear the parentheses. So that's 3x plus, what is that, 320 equals 7x plus 280. And then I'm going to subtract 7x to both sides, subtract 320 to both sides. And so that's going to give me negative 4x equals, I think that's negative 40. And then divide everything by negative 4. That is going to be x equals 10 ounces. Okay. And there's my answer for that one. All right. So now let's look at this one. Oh, another mixture problem. How many gallons of a 15% alcohol solution and how many gallons of a 10% alcohol solution should be mixed together to obtain 20 gallons that contain 12% alcohol? Well, let's do our containers again. All right, so let's see what we have. We're mixing together a 15% and a 10%, right? The 15 and the 10 we're mixing together. And in the end, we want a 12%. Well, in this problem, they tell us that what we want total is we want 20 gallons total, right? And they want to know how much of each one. How many gallons of each do we need to get this? All right, so a lot of times what students will do is they'll put this, X and Y. Okay? And actually, you can solve it like that, but we don't know how to solve a system of equations yet. Okay, that's later on in a college algebra course. So we don't need the two variables. So let's just look at this. If this is X, so let's say I say, okay, I'm going to have X gallons of a 15% alcohol solution. Well, if I have X gallons here, how many am I going to have here? 20 minus X. Does that make sense? Well, let's look at it. So let's just say here, let's say I have 5 gallons. So if this is 5 gallons, how much is this? 15, right? Because it's got to equal 20. So in other words, if I've got 5 gallons here, then 20 minus 5 is the 15. That's where this 20 minus X comes in. Okay? Now, why didn't I let X be the number of gallons in the 10% alcohol solution? Well, I could have. Okay? You could have done that. I just chose to let it be the 15%. No particular reason, I guess, maybe just because it was the first one. Okay? All right, so now let's go ahead and set up our equation. So I got 15% of this, so that's 0.15x plus 10% of this many gallons, so 0.1 times 20 minus x equals, and then 12% of the 20 gallons. Now, once again on this one, I would go ahead and get rid of the decimals. I hope now you can see, when to get rid of the decimals and when you really don't need to, because it would be easier not to. Remember the problem we worked before with the tax, with the sales tax? Okay? So, it's just simple stuff like that, when to get rid of the decimals, when not to. If you want to, you can get rid of the decimals every time, or you don't have to get rid of them any. Okay, you can use calculators. All right, so let's go ahead and get rid of the decimal. So what I'm going to do is I'm going to multiply everything by what? Well, the most I need to move the decimal to the right is 100. So I'm going to multiply everything by 100. That's going to give me 15x plus 10 times 20 minus x equals 12 times 20. And then let's clear the parentheses here. So that's going to be 15x plus 200 minus 10x equals 240. Let's combine like terms. So 5x plus 200 equals 240. And then I'll subtract 200 to both sides. And so that's going to be 5x equals 40. Divide everything by 8. And so I get x equal 5. And that's what? Gallons. Look at that. And honestly, to tell you the truth, when I used the 5 and 15 up here, I had no idea it would be 5 for an answer. Whoop. And you know what? It's not, is it? Huh. And see, and you know what? Actually, I did that on purpose to show you always pay attention to what you're doing. Okay? You see how I divided both sides by 8? I had an 8 here. And I guess what I was doing, I went ahead and divided it in my head and wrote down the 8 down here. But it's divided by 5, and so that equals 8. Okay? So just disregard what I was explaining up here about picking the 5 and 15. But no, it's 8 gallons. So this is the number of gallons of the 15% solution. And then we've got 20 minus x is equal to 20 minus 8. X is 8, which is 12 gallons. And that is the 10% solution. So this is your answer. This one and this one, they wanted to know how many gallons of each, right? Okay. So yeah, just that mistake I made. See, that's what I'm talking about. Just careless mistakes. I do it too. Okay. All right, so let's look at this one. It says Rita can process a batch of insurance claims in 4 hours working alone. Eduardo can process a batch of insurance claims in 2 hours working alone. How long would it take them to process a batch of insurance claims if they worked together? All right, so this is an amount of work problem. So on these, I would make a table. So we've got Rita and we've got Eduardo. And I've got rate, time, and amount of work. And your formula, amount of work is equal to rate times time. All right, so now let's fill out the table. All right. So it says Rita can process a batch of insurance claims in 4 hours working alone. In 4 hours working alone. So what's her rate? What's the rate that she's working? Well, let's look at this. Let's talk about mowing a yard. So let's say if you're mowing a yard, let's say it takes you 3 hours to mow the entire yard. Okay, it takes you 3 hours to mow the entire yard. Then that means you're doing a third of the job per hour, right? If it takes you 3 hours, you're doing a third of the yard per hour. Well, that's your rate, 1/3 of the job per hour. So if it takes her 4 hours to process the claims, then what's her rate? That's 1/4, right? Now, it says Eduardo can process a batch of insurance claims in 2 hours working alone. So what's his rate? Well, that's 1/2. Okay. All right. So hopefully you understand about the rate. It's how much of the job are you getting done per hour, or how much of the job are you getting done per minute, or per day, or per week. In this case, they're talking about hours, so it's hours. Now, what about the time? How long is it going to take them? Well, that's actually what we're trying to find out. How long is it going to take them working together? So the time would be what? X. And then what would Eduardo's time be? Well, guess what? It would be X also. Because isn't X the time it takes them working together? So if they start at, say, 8 o'clock in the morning, and they work until 10 o'clock, they're working together to get them all done. So they're working from 8 to 10 o'clock. They're both working the same amount of time. It's just one person is what? Is doing more claims than the other one, but the time that they're working is the same. So that's why this time here, that's the same on both of them. And then the amount of work is just rate times time. So that's X over 4, and this is X over 2. All right. So what I'm going to do here is I'm going to go ahead and I'm going to write down our equation. I'm going to write it down, and then I'm going to explain to you how we got it. Okay. And after I write it down, pause the video and see if you can figure out how I came up with it. So our equation would be X over 4 plus X over 2 equals 1. Pause the video and see if you can figure out how I got that. All right, so let's look and see how we came up with that. How did I get that? How did I get the 1? So let's look at this. Let's go back here to mowing the yard. All right, so let's mow a yard. So let's say that we're mowing yards together, okay? We're working together mowing yards. And I'm going to start on this end and mow the yard, and you're going to start on this end to mow the yard. And let's say that we got a push mower and we got a riding lawn mower, and I get to use the riding lawn mower, and you have to use the push mower. So more than likely, I'm going to mow more of the yard than you are. So let's say that I mow 70% of the yard, then that means you'll mow what? 30% of the yard, right? And the 70% plus the 30% is equal to 100% of the job getting done, right? But what if I put it in decimal? 0.7 plus 0.3 equals 1, right? See, this 0.7 here, or 70%, however you want to look at it, but this 70%, this is the amount of work that I did. This is the amount of work that you did. So the amount of work that this person did, Rita did, plus the amount of work that Eduardo did is equal to 100% of the job being done. And that's where that equation comes from. I hope that made sense. I hope it didn't confuse you any. All right. So now that we have our equation set up, now we can just solve it. So let's multiply everything by 4, the common denominator. So that's 4 times x over 4 plus 4 times x over 2 equals 4 times 1. And so this is going to be x plus 2x, the 4 and the 2 cancel, equals 4. And so that's 3x equal 4. And divide both sides by 3. That's going to give me x is equal to 4/3 hours. So that's 4 and 1. That's 1 1/3 hour. Okay, hour and 20 minutes. Okay. All right, let's look at this. Oh, look at that. This is the last problem. We were having fun, weren't we? I probably don't have anybody hanging around right now still watching this thing. Be like I'm just talking to myself on this problem, right? All right, so let's see. It says Dana inserted 8 coins consisting of dimes and nickels into a vending machine to purchase a Snickers bar for 55 cents. How many coins of each type did she use? All right, so I think we can work this one. So she's got 8 coins total, right? And they're dimes and nickels. And she wants to know how many of each type. Well, what if I come over here? I'm going to let x equal the number of... I'm going to let x equal the number of nickels. So why did I let x equal the number of nickels? I don't know. I just did. You could let x equal the number of dimes. Okay? It doesn't matter. Just let x equal one of them. In this case, it doesn't matter. If you remember before, I said let x equal the one that they don't give you any information about. You know, when we did the rectangle, I let x equal, I think it was the width. But in this one, they don't tell us anything about dimes. They don't tell us anything about nickels. So just pick one. Okay. And so if x is the number of nickels, then what is the number of dimes? Well, that would be what? 8 minus x. And this right here is the same thing that I explained to you when we were doing the mixture problems. Remember in this problem like that. Because think about it. You've got 8 coins total, right? Well, if you have 2 nickels, how many dimes do you have? You got 6, don't you? And how do you get that? Well, if you got 2 nickels, because X is nickels, if you plug 2 into there, 8 minus 2 is 6. All right. All right, so now let's set up our equation. So to set up our equation, it's the amount of money that we have in nickels plus the amount of money we have in dimes is equal to the 55 cents. So what's the amount of money I have in nickels? Well, that is 0.05 times the number of nickels. Isn't that what you do? The value of the money times however many of those you have, and that gives you how much you have in nickels, dimes, or quarters, whatever you're dealing with. Okay, so the value of a nickel, that would be what? 0.05 in terms of dollars, right? What's the value of a dime? 0.1. A quarter would be what? 0.25. 50-cent piece, 0.5. Okay. And a penny is what? 0.01. So this is the amount of money I have in nickels plus the amount of money I have in dimes. So that's the value of a dime, which is 0.1, times the number of dimes I have. And that is equal to 55 cents. And that is going to be, we're going to write it in dollars, so that's 0.55. So now I have another equation with decimals. Okay. Man, let me tell you, if you've been watching all these videos I've been doing, you're going to be good at solving equations with decimals. All right. So we got to get rid of the decimals. We're going to multiply everything by 100. So that moves the decimal 2 places to the right. So that's going to be 5x plus 10 times 8 minus x equals 55. Okay. Now let's clear the parentheses here. So that's 5x plus 80 minus 10x equals 55. And then, of course, we're going to what? We're going to combine like terms. So I've got negative, what is that? Negative 5x plus 80 is equal to 55. All right, so let's make sure I've got all this down right. So that's 5x, 10 times that, and that's 55. So that's going to be 80 minus 10. Okay, I think we're good. So now I'm going to subtract 80 to both sides. Okay, just going back through and make sure I didn't make a careless mistake. Whenever I make a careless mistake, I always hear it in the comments. All right. So I've got negative 5x equals, this is going to be negative 25. And then I'm going to divide both sides by negative 5. And that is going to give me x equal 5. And so I've got 5 nickels. And so how many dimes do I have? Right there. 8 minus x, which is 8 minus 5, equals 3 dimes. Five nickels and 3 dimes. And that's all of the lesson. So I hope that helped. You probably feel a lot smarter now, don't you? So check out my other videos. Give me a like, share, and subscribe. And thanks for watching.